Okay. Good morning, good afternoon, students. My name is Mr. Chimanda. Welcome to our new lesson on logarithms. So today we'll be continuing with logarithms, like what we have been doing since yesterday. We took up logarithms so that they can help us also to do exponential functions, which are so logarithms is an integral part of exponential functions. So we're just going to continue today. We started in the middle of the lesson yesterday, but we're going to continue today. We started with three basic laws of logarithms. I'm just going to quickly repeat them because there's a little bit more. So I'm going to quickly repeat what I said yesterday, then we can continue with our laws of logarithms. So thank you very much. Let's get to work. All right, so we're continuing with logarithms. So yesterday, just a recap, we said a logarithm is a power. A logarithm is a power, right? If I say 2 to the power 3 is equal to 8, so the log of 2, right? So the power of 2, that gives me 8 is 3. That is what we said yesterday. Right? I'm just going to quickly look here. Everyone. Right. So sometimes I will continue to explain, then I'll answer to questions later on. So today we are covering logarithms. So logarithms, we said, is a power or it's an exponent. So what is the power of 2 that gives me an 8? It is 3, right? So if I write it down, the log 8 is equal to 3. We're saying the power of 2 that gives me 8 is equal to 3. That's how I'm writing it down. But if I'm looking at it this way, so with this one, it is easy. It is easier to solve because I can quickly convert this also. I can quickly convert it to the same base. An example, if I have 2 to the power x is equal to 16, I can quickly convert this 16 and put it to the base 2. So I can say 2 to the power x is equals to 2 to the power 4. You can easily do this using a calculator, right? So if the bases are the same, then we can conclude that the powers are also the same. If the bases are the same, the powers are the same. So it's x is equal to 4. I've quickly solved. But it's not in all cases that we get exact, that we can convert to exact bases and get the power as an integer. So we can ask ourselves, what is the power of 2 that gives me 16, right? That's where logarithms come in now. So this was just an introduction to show you what logarithms are. For those who didn't know, logarithms are powers. So I'm saying, what is the power of 2 that gives me an 8? It is 3, right? And here, so we spoke about the laws of logarithms. So if we go to laws of logarithms, law number 1, we said it is multiplication. Multiplication law. The multiplication law states that log, so A, B, and C. So you can, so it's, if we say log, this becomes what is known as a base. So we always have a base here, whatever number it is. So the base is the same base we have here. Well, that is the base of the power. Remember, this is an exponent and this is a base. So log to base A of BC. BC is multiplied. So this becomes log to base A of B plus log to base A of C. So what we, in literal sense, what we mean is if we have log BC, if it is multiplied here, then here we add. Here we add. Law number 2, it is log of B over C. So this one now, it is known as the division law. It is known as the division law. We spoke about it yesterday. This is the multiplication law, the first one. This one is the division law, where we say this is equal to log to base A of B minus log to base A of C. So the division law makes us subtract. So when we have a fraction or something over the other, we subtract. We also give examples. So we shall continue when we do when we do our examples. Law number 3. These are important laws. You must try to memorize them. They are very critical. Law number 3 is derived from the multiplication law, which is a very important law, which enables us to solve exponential equations. So I'm going to come back here. So if I'm going to drop the bases because we can actually see the bases are the same. So for simplicity, I'll not write the bases. So if I have log A, B, C, by the multiplication law, this becomes log A plus log B plus log C. Because if I have anything that is multiplied, I add. That is what the multiplication law states. Right? So from this one now, what if I have log A, A, A? I have 3 A's. So this becomes log A plus log A plus log A, which I can quickly write as log, because how many logs do I have? I have 3 of them, 3 log A, because they are the same, right? So in this case, but this one I can, instead of writing A, and A, I can write it as log A to the power 3. So what I realize from this notion is that if I have to the power 3, then I get 3 logs if they are the same. If they are not the same, I spread it out like I did in the first example here, where I said log A, B, C is equals to log A plus log B plus log C. But in this case, the variables here are the same. So it's A, which is log A plus log A plus log A. But this log A, I can write it as A to the power 3. So this power, I can notice that this power is giving me 3 of the variables. So what should I do? I can now quickly interpret now. They say, okay, in general, if I have log A to the power n, n being a number that represents, here I have 3. Here I'm just putting it in arbitrary number, which can be any number. It is equal to, but I can see that this 3, I can now, it becomes, in science language, we say it comes down. So this becomes n log A. This is my third law. So we have law number 1, the multiplication, law number 2. So this one is also derived from the law of multiplication in the sense that we have the same variable, but to a power. So it becomes n. So an example, if I have log 2 to the power 4, it is equals to log 2 plus log 2 plus log 2 plus log 2. But this now is a longer process, because this will give me 4 log 2. But instead of me going this way, I can simply go down and say this becomes 4 log 2 straight. Instead of me going through the process of expanding and what, I can simply come down and write it like this. So this is a very important law that we will be using to solve exponential functions. So please keep it in mind, or you must try to memorize it as we are doing examples. Let's go to law number 4. Law number 4. Law number 4, it states that log 1 is equal to 0 here to any base. Log 1 is equal to 0 at any base. What do I mean? What do I mean is, if I have, I'm just going to quickly divide my page so that we are able to see, all of us, right? What do I mean? Remember, in exponentials, right, if I have a to the power 0 is equal to 1, what we mean is any number to the power 0 is equal to 1, right? It is the 0, power 0, it's called power 0, is the power 0. Right. So a to the power 0 is equal to 1. So if I write 2 million or 200 to the power 0 is equal to 1 by the laws of exponents, right? So what is the power of 200? That gives me 1 is 0, right? What is the power of 200? That gives me 1, it's 0. That's why we say log 1 is 0. So that is the fourth law of logarithm. So we can use these laws interchangeably. If I say interchangeably, I mean here, I can move from this part going and simplifying it like this, or I can move from this part simplifying it and going this way. Right. Or I can move from this part to this part, and this part to this part, or this part to back. Or I can move from this part to this part, or this part to that part. So some of the laws, for you to understand them, we would need to do some examples. So some of our laws, or there are some of their proofs that come from laws. So let's do an example. Example, we're going to quickly do an example for the multiplication law, and we want to prove it using a calculator. So if I have log 3 times 2, which is, I will say this is equals to log 3 plus log 2. If in normal circumstances, if I don't write anything on the base, it means it is to base 10. That is the norm, it is to base 10. But if I want to express it to another base, then I must write the base. But if I do not write the base, it is to base 10. So you can check, because this becomes log 6. You can quickly check on your calculator to see, does log 6 give you log 6, is it similar to log 3 plus log 2? If you can quickly check, I'll give you 10 seconds to do that. You can quickly identify that it is the same. Now, let's go to another example. So this is example number 1. Example number 2, if I have log 7 over 4, this is equal to log 7 plus log 4. Right? You can quickly, not plus, sorry, minus. Because we said if it's a reciprocal, it's minus. So from this one, we can also derive a fifth law before I engage that one. From this one, I can derive law number 5. It's called the reciprocal law. What does the reciprocal law say? It says if I have log 1 over a, it's 1, not any other number, it's just 1. This is equal to negative log a. So with this one, there are several ways to prove it, right? I'm going to write proof number 1. How do I prove that log 1 over a is equal to negative log a? Proof number 1. By the law of division, it says if I have log, if I have something like this, this becomes, if I have log a over b, it is equal to log a minus log b. Right. This is the law. I've just written the law. So this is the law. Right. So in this case, if I check this one, I'm going to bring it here. If I check this one, this becomes log 1 minus log a. But we, in our here, we said log 1 is equal to what? Log 1 is equal to 0. So this becomes 0 minus log a, which we can simply write as minus log a, which is, so that is what I was saying, is some of the laws are generated from our main laws. That if you have log 1 over, right? Oh, this cannot be written like this sometimes. It can just be written, okay, this is proof number 1. What happened to the 4 in the denominator? This one. It's log 7 over 4, which is equal to log 7 minus log 4. Here we don't have any numbers yet. Right. It's an A. Okay, sorry. So in this one now, proof number 2. Proof number 2. This one is an A. Sorry, my handwriting, it's an A. Right. Proof number 2, I can say, if I remember, I'm going to explain here a little bit, so that I always try to utilize my page, right? If I have a 1 over a, I can write it as a to the power negative 1. Right. As I'll repeat the same process. If I have 1 over a, I can write it as a to the power negative 1. So if I have 1 over x squared, it means I can write it as x to the power negative 2. Or if I have x to the power for negative 4, I can write it as 1 over x to the power 4. So it means the reciprocal of any number changes the sign, right? Changes the sign. So here you can actually see when I bring it down, the sign changes. Here, it is to the power 1, but if I bring it up, the power becomes negative. If here the power is positive, if I bring it up, because if I find it is basically saying over 1, and this one is also basically saying over 1. So if I tip it up, so that's where proof number 2 comes in. So log 1 over a is equal to log a to the power negative 1. But remember, by the laws of exponents, which I have here, the laws of exponents, this one, which says log a to the power n is equal to n log a. I'm going to bring it back. So it means I am going to multiply by the power, which is equal to -1 log A. So these proofs are not necessary though. It's just showing you that this is correct. Because in your examination, you will not be asked to prove, but it's just to show you that this is true for the law. Because remember, a law is something that has been verified. It differs from a theory where it might work for some and it might not work for some, but a law is clearly defined and it follows a particular rule. Right? So that is the fifth law of logarithms. Right. Now let's go. I will derive the sixth one when I'm by using an example. The sixth law. Right. So we call them law. You can derive as many laws as you want, as long as they all come from the multiplication, division, and the reciprocal. So this one I will use an example. Example. If I have 2 to the power x is equal to 32. Is equal to what? To 32. And I want to solve for this. What I will do is I can either use my exponents and, okay, say 2 to the power x, I can convert this to be the same base as this one. So this is 2 to the power 5. Then I can quickly say x is equal to 5. I have solved because it says solve for x. So I've solved for x. So 2, I've made them the same base, which is easier because I have a 32. If I had a 33 here, then it would be very different. So the easiest thing is to come and introduce logarithms, both sides. So if you introduce logarithms, we have log 2 to the power x is equal to log 32. Right? I've just introduced the logs, both sides. But by the exponential law, it says if I have log x to the power 2, the x comes down. So it becomes x log 2 using the law. This remains as log what? 32. Correct? Now the last thing is to divide by log 2. Both sides. I have log 2. I can cancel out. Do not make a mistake of canceling out the logs. It will be very wrong. And notice that this is not similar to log 32 over 2. It is not similar, right? It is not what? Similar. So if you want now, go on your calculator and punch in log 32, then you put over, or you can actually say log 32 divided by log 2. See, does it give you a 5? Yes, it will give you a 5. You see? Say, would you always cancel out the side that has an x? The reason we're canceling out here is we are trying to make x the subject of the formula. That's why we divided by log 2. So the reason why we cancel is we're trying to make x the subject of the formula. Right? So this and this is not the same. The moment you punch in your calculator and say log 32 over 2, it is totally different from log 32 over log 2. So from here now, watch carefully. we can now derive our sixth law or our sixth statement. Right? So please pay attention. Here we said, what is the power of 2 that gives me 32? Remember, when you're talking about logarithms, right? What is the power of 2 that gives me a 32? It's x. So when I write it in log form, I write it as log 32. And yes, 2. So it is equal to x. Yes. So what the power of 2 that gives me 32 is x. Right? But remember, x, we have also written it is equal to log 32 over log 2. Here, when we solved. Right? I'll repeat that again. What is the power of 2 that gives me 32? It's x. That's how I can write it here, to put it in log form. But remember, when we solved for x again, we said x is equal to log 32 over log 2. So if I eliminate this x now, this I can now get and say this is equal to, so log 2 over 32 is equal to log 32 over log 2. You can check, go on your calculator, punch in log 32 to base 2 quickly. Right? You will get 5. And punch log, this we have already seen that it is 5. So log 32 to base 2, don't forget, right? We get 5. And log 32 over 2. So we are going to write it in general form, right? So in general form, log A to base B is equal to log B over log A. Those are the 3 examples. So, okay, someone is asking, how do I how do I use log to base 2? Let me quickly grab my calculator. Okay, I'm sorry for the short delay. There, I've just got my calculator. So I'm just gonna quickly show you how do you punch in into your calculator. So we have 2 log buttons. We have this log, and so we have 2 buttons, right? We have this one. If you punch, it just gives you log. And we have this one just before, if you punch in, it gives you log, with where you can also put the base, and you put 32. You see, it will give you a 5. Right? So I think it answers you, how do you write log to base 2? If this one, it's log to base 10. Right? So you can actually use that one. But when you want to write log 32, so you have log 32 over log log 2. Right? So you see, you can get what? You can get 5. Right? So now, the trick about it is you must, these 2 must be the same base. They must be the same what? they must be the same base. So even if I put 5, I must also put 5. I cannot have log b to the power to base 2, then I have log to base 6. Okay, what is the 6th law code? Okay, this one I don't have a name for it, but I mean it's let's call it the 6th law. Let's call it the 6th law of logarithms, right? So that we don't have to confuse ourselves. So what we're saying, what we're doing is the 3 main basic, right, is the division, the multiplication, and the exponential law. Everything else is derived from those. So you can even derive your own. You can even today, if you want to be a good mathematician, you can play around with logarithms and you can actually maybe determine some things that are hidden in them that we did not know, right? So I'm going to quickly share my screen for my textbook that I use. Remember, we use Siavula, the textbook, which is recommended. Say, would we need to add or subtract log fractions? Log fractions, I think I explained on the division law. So I want to quickly share a screen here. Okay. I'm going to, before I explain this, I'm going to quickly do the 7th law, right? The 7th law. So let's call it the 7th law. So what you see, so we always use the phenomena that we have. Okay, Carlos, if you can give me sort of a writing of what you mean so that I can see, because I'm not understanding your question, but so long I'm going to explain the 7th law. So the 7th law, it states that, remember, I'm gonna quickly come here. So 3 to the power 1 just gives me a 3. So it says, if I'm writing it in log form, I'll say the power of 3 that gives me 3 is what? Is 1. The power of 3 that gives me a 3 is 1. Is that correct? So in general, right? The power log A to base A is equal to 1. Right? Log A, so this to its base is equal to 1. So I'm saying if I say log, if I say what is log 4 to base 4, you must be able to say it is equal to 1 quickly without any problems. If I say log x to base x, it is equal to 1. So it is basically say a log of a number to its base is equal to 1. I'm just going to quickly try to help on the question that was asked, that it says log 6 plus log 3 divided by log, right, plus log 7 divided by log 5. So you can actually see that these two, they are dividing. So this becomes log 6 over log 3 by BODMAS, right? Then plus log 7 over log 5. You can simplify this however you want. You can put this as one number. This you can write it as log to base 3 of 6 plus log to base 5 of 7. Since they have different bases, we leave them like this. We cannot add them. This comes from the laws that I just explained. So that's why I just wanted to help you there. Right. So I'm going to quickly share. I hope you have understood the laws that we have right now. Right. So let's try to do some questions. Right. Applying the laws of logarithms. So we have this one. So this is an exercise. This is exercise 2.7. So this is applying this rule, which you bring down the power. You see, you bring down the what? The power. So we're just gonna do two examples where we have number 5. Yeah, number 5. It says log y, right? Number 6. Then I'm going to do number 10. It says log okay. And we're just going to quickly do these two so that to see, do we understand? I'm going to stop sharing. So I've taken down number 5 and I've taken down number 9. Taken down number 5 and I've taken down number 9, which we can now do as examples to see, did we understand? So I'll stop sharing. Okay. Someone says do number 7. Let me check number 7 as well. 7 and 12. I think that is what we'll do on this section. Number 7. Okay, number 7 says log to base 2 power 4. Number 12, it says log to base 2 of 0.125. Thank you. So I have number 5, number 9, number 7, and number 12. That is what we are going to be doing as our examples. I'm going to stop sharing. So let's see number 5 first. So we're going to start with number 5. So number 5, I believe you all know the laws of exponents. I'm just going to write them here again so that you understand. If I have square root of x, it means it is written as the 2 is not just put in. Why? Because we know that we only put when you come to 3 and 4 and 5 and any other number greater than 2. If it's not written here, then you know it's a square root. And if it's a cube root, they actually say it's a cube root. They put a 3 here. But in this, if it's not x squared, but this is x to the power half. Right? That's x to the power what? X to the power half. So it means if I have the cube root of x, this is x to the power 1 over 3. If I have the 15th root of x, this is x to the power 1 over 15. This is x to the power 1 over 15. So now when you come back here now, number 5, So this is just like saying log y to the power 1 over x to base y, right? Which we can now write, use the laws of logarithm. So I'm going to use this one first, where I bring 1 over x down. Right? So 1 over x log y to base y, right? If you can check that. So the first, we brought this down. The second one, we're now, but remember the 7th law that I just taught you right now. What does the 11th law say? The 7th law. It says a log of a figure to its base, it's 1. So it's 1 over x times 1, which is just 1 over x. I've solved using the laws of logarithms. Right? Number 7. Let's do number 7. Number 7, I can now come and say log 2, 8 to the power 1 over 4. Then, because it's the 4th root, which is equal to 1 over 4 log 8 to base 2. But log 8 to base 2, if you check or if you punch it in the calculator, you get a 3. So this is 1 over 4 times 3. Right? Which is equal to what? So 1 over 4 times 3, what do you get? You get 3 over 4. Final answers. Right? Final answer. So you can see it's just using your, if you memorize and know all of your logarithms, it will be very easy. So we're going to quickly do number 12 before our time is over. So I'm going to write number 12. Number 12. It says log to base 2 of 0.1 to 5. Right? 0.1 to 5. So the question now, what is 0.125? That is the question. 0.125. 0.125 is a decimal. How do we express it as a fraction? 0.125. Okay, I will teach you now on how to change it. So you come and say 0.125. So you see, it actually gives you, it is equals to 1 over what? 1 over 8. If it's 1 over 8, now I can write it as log to base 2 of 1 over 8. Which now I can write using my law as next a negative log to 8, using the laws of reciprocal, if you check the before, which I can now, was log 2 to base 8 is 3. So this is equal to negative 3. So you can see that answering these questions, sorry. So I'm going, yes, I will continue to, I will do it tomorrow. It's, we are just out of time today. So I'm just going to quickly share my screen so that we can also take some questions and be able to do. But I hope most of you are able to download this book. It is not difficult to download. So this I think we can try to convert to base 8, applying this law. So you do exercise 2, right? Then here it's just using the logarithms using a calculator, right? So we will go back to exponential functions, but we'll continue to do more examples tomorrow so that we are able to, right? So please show the notes on exponential function, right? So thank you very much for coming in today. This is the notes. So thank you very much for coming in today. The name of the book is the Siavula book, right? Which I'm using. It is very useful. And I will thank you again for, let's meet tomorrow again, where we do more examples. I hope you have learned a lesson, and thank you for being nice today and for being kind and for being respectful and for being attentive. Thank you. We meet tomorrow.